Hi guys, so we're going to go into a difference of means and significance test for difference of means. But before we do that, we're going to first review sampling distributions and how we describe them for a difference of means. We first did this in Unit 5, but I know it's been a while since we did that, so let's review. So first off, let's look at our situation. Let's say last year, Francis Lewis had 30 students take the stats exam for the AP test. And as some of you may know, there are two forms of the exam, Form A and a Form B. And let's say these were the results that Francis Lewis got. So Form A, we have these top results, and Form B, we have the bottom results. So the mean score from Form A is 4.2, and from Form B is 4. So we can see our difference is 0.2. Now these two forms are supposed to be pretty much the same difficulty. So assuming that the two forms are the same difficulty, let's say if Brian scored a 5 on Form A, he should also score 5 on Form B. Brian is a 5 no matter which form he is assigned. But now we want to determine this difference of 0.2. Is this like common, or is this evidence that these two forms were not actually the same difficulty? So we were going to do an experiment class with this. We were going to have a little activity where I had all these scores on cards and passed them out. And we would just randomly have half the class be Form A, half the class be Form B, give out these 30 cards, and figure out what's the average for Form A students, what's the average for Form B students. And then we'd find a difference. Now, we can't do that anymore. So I have the next best thing, which is a simulation. So in group 1, I've put all the Form A scores. In group B, I've put all the Form B scores. And below, not that, but down here, I have simulated what I described. So just randomly passing out these scores. And I've done it 33 times, so one for each student in the class. So 33 samples altogether, and this is the dot plot that I got. So please take a second to copy down this dot plot. So pause the video for a minute. Oops. All right, now let's start analyzing the data we got from this dot plot. Let me go back to, here we go. All right, I have copied this dot plot onto here. Ignore the little ends over here. Pretend that's not there. Ignore. But we are asked the question, Francis Lewis had a difference in mean scores of 0.2. Is this outcome surprising? Now, remember we mixed up all of the scores and randomly distributed it and just said like, this half is Form A and this half is Form B. Find your average. And then with the simulation, we did that 33 times. We just randomly distributed the scores and said, randomly, these are A, these are B. So this dot plot shows us what would happen if Form A and Form B, the scores were just random, which means that the two forms should be equal. So let's take a look. If the two forms are the same difficulty, then a difference in means of 0.2, those are these scores and above, these scores and below. How surprising is it to get a difference of 0.2 or more? Well, we can see from the dot plot that this happens fairly often. Out of 33 dots, we only have 8, 4 here and 4 here, that have less than that difference. So subtracting those 8, that means 25 out of 33 dots, which is 75.757%. So 75% of the time, we're going to get a difference of 0.2 or more. As such, is this outcome surprising to have that difference? No. This outcome is not surprising. Why is it not surprising? Because 75.75757% means that a difference of 0.02, let me scroll so I have some more room to write, means a difference of 0.2, so greater than or equal to 0.2, is likely to happen by chance. God, I hate my handwriting on this thing, but we do what we can do. All right, so not surprising, it happens so often, more than 75% of the time. All right, so to extend this question a little bit more, let's look at the back of the worksheet, which says, based on the simulation, do we have convincing evidence that one form of the exam is harder? Now remember, we just got a result of 75%. That's a p-value, because remember, a p-value is a probability value or a proportion. So since we have a p-value of 75%, do we have convincing evidence? No, because 75% is greater than, and what's our standard percent that we are looking to compare to? It's greater than 5%. So 75% is greater than 5%. We do not have evidence, or we do not have convincing evidence. Sorry. Convincing evidence that one form of the exam is harder. So obviously you can see we're going into significance tests, and this is for a difference in means. We had two sets of data, we took the means, and then we found the difference. All right, the important ideas, the big ideas, of course, see Google Classroom, I'm not going to copy them down here and waste time, but we're going to go over them in the workshop below. So remember, we learned how to describe a sampling distribution. And the three things we want to be able to describe are the shape, the center, and the spread. The three of our letters for SUCS. Now, in this workshop, we have heights of young men and young women. They give us some information, the mean, the standard deviation. That should not say S, that should say sigma, which it should say in your worksheet. Let's see, that should be sigma, that should be mu. That should be sigma, and that should be mu. All right, so we have these. We have two simple random samples of young men and women. What is the shape of the sampling distribution and why? Now, sampling distribution, you can look at three things. It's the same three conditions we look at when we are calculating, when we're determining the shape for a confidence interval or for a significance test for means. To find shape, we look for 1, CLT. Is our sample greater than 30? Now here's the thing. How many samples do we have? We've got 2 samples. So we need to make sure each of these samples is greater than 30. So our 2 sample sizes are 16 and 9. Neither of them are greater than 30. All right, CLT is not going to help us. Second thing we look for, are the populations approximately normal? So let's look, the population of young men, and we are in luck here. The populations of young men follow a normal distribution. What about the population for young women. Heights of young women follow a normal distribution. So yay, we are able to use that to tell about the shape of the sampling distribution. This is normal because both populations are normal. Now remember, if that was not true, if we weren't told, you'd have to follow our least favorite. We'd have to probably graph our data and determine if we had any strong skew or any outliers, but we do not have to do that in this case. All right, let's look at the next question. Find the mean of the sampling distribution. Now, remember again, we have two samples here. To find the mean of the sampling distribution, our formula for that is mu of whatever our first mu is minus our second mu. So in this case, we have mu of men. Let me fix that. So mu of young men minus mu of young women. And those are given to us. Let's see, young men is 69.3 minus 64.5, and that is a difference of 4.8. So there is our mean. All right, lastly, calculate and interpret a standard deviation of the sampling distribution of these differences. Go away, there we go. All right, standard deviation, this formula is in your reference sheet. But just to, what happened? All right, just to reiterate it, you have sigma of xm minus sigma of xw. Sorry, the x bars. Get rid of that bar above the m. Oh my god. Let's start over. Sigma of x bar m minus x bar w. This is going to equal the square root of sigma of the men squared over n for the men plus sigma for the women squared over n for the women. And all of these numbers are given to us. Sigma for the men is 2.8. How many young men? 16. Sigma for the women was 2.5. And there were 9 young women. So if you calculate that, you will get 1.088. And to interpret this, basic interpretation for standard deviation, except remember, this is a difference in means. So the difference in our sample means, because these numbers were pulled from a sample, typically vary by, and our number we just got, 1.088, from the true difference in means. True, and I'm going to abbreviate this, true difference in means, which was 4.8. So same format, but just remember it is a difference in means. All right, you have a very short homework, only number 38 and 46A. Please remember to copy down your big ideas from Google Classroom and email me with any questions. All right, guys, stay safe, stay sane while you're stuck indoors, and do your best to just make sure everybody else around you does so as well. Bye, guys.